All right, we are continuing to talk about rational exponents and solving some equations with rational exponents, but first we're going to do a quick review on writing rational exponents from radicals and combining like terms. So if we wanted to rewrite all of these in simplest exponent form, first they need to be written in exponent form. So if I have the fifth root of 5, that is equivalent to 5 to the 1/5 power, times I have the fifth root of 5 squared, that is equivalent to 5 to the 2/5 power. So if I was going to combine them, this would just be my product rule. I would add my exponents, and we are fortunate that they already have a common denominator, so this would be 5 to the 3/5. On the next one, I need to rewrite both of these in exponent form. Square root of 7 is equivalent to 7 to the 1/2 power, and that's going to be times the fifth root of 7 to the 6th. That's equivalent to 7 to the 6/5 power. If I'm going to add these exponents, I'm going to need a common denominator between 1/2 and 6/5. The least common multiple between 2 and 5 is 10. So I'm going to rewrite each of those with a denominator of 10. So I would have 5 over 10 and 12 over 10. So that's going to give me a total of 17 over 10. So 7 to the 17 over 10 power. I'm going to box these just so they don't get lost. Okay. Cube root of 2, that's equivalent to 2 to the 1/3. Fourth root of 2 to the 5th, that is equivalent to 2 to the 5/4 power. To add those, again, I'm going to need a common denominator. The least common multiple between 3 and 4 is 12. So this will be 4 over 12, and this will be 15 over 12. So I'm going to get a grand total of 19 over 12. So 2 to the 19 over 12 power. All right, and then last one, cube root of 10 to the 5th, that's equivalent to 10 to the 5/3 times cube root of 10 squared is 10 to the 2/3. We are fortunate that these exponents already have a common denominator, and when I add those, I will get 7/3. So 10 to the 7/3 power. All right, on the next ones, we are going to rewrite these in simplest radical form. So what that means is, if you end up with a perfect cube or a perfect square, etc., simplify it. So the first one I have is 64 to the 2/3 power. So that means the cube root of 64 squared. Now, 64 is a perfect cube. The cube root of 64 is 4. And 4 squared, 16. All right, on the next one, I have 1 over 6x to the 4/5. The 4/5 is only applying to the x, so that's going to be 1 over 6 to the 5th root of x to the 4th. And I don't know what x is, so I can't simplify it any further. On the next one, this 6/5 power, again, is only applying to the x, so that 3,125 will stay in the front, and then I will have the 5th root of x to the 6th power. I don't know what x is, but I could split this up into x to the 5th times x to the 1, kind of like when you're simplifying radicals, and I could bring out a fifth root of x to the 5th, which would just be x, and then I have the 5th root of x to the 1 inside. Okay, on the next one, this is all to the 1/2 power, so it's going to be the square root of 25x cubed. 5 is a perfect square, so I can bring out a 5, and while x to the 3rd is not a perfect square, I can split it into x squared and x to the 1. The square root of x squared is x. And then I have the square root of x to the 1st power still inside. Okay, solving equations with rational exponents. We are going to isolate our base using our inverse operations. Then you are going to raise both sides of the equation to your exponent's reciprocal. That just means you're flipping the fraction upside down, and then you'll continue to do whatever operations are necessary to get your x alone. Now, again, this next test is going to be non-calculator, so we are going to go through this without a calculator, and if we can't evaluate some of these values by hand, we will just leave them in exact form. So, starting on A, I need to get x alone, so the first thing I'm going to do is add 4 to both sides. So that will be equal to 400. Then I can divide everything by 7. Now 400 is not going to evenly divide by 7, so I'm going to leave it as a fraction. Now I need to raise both sides to my reciprocal power. Well, the reciprocal of 6/5 is 5 over 6 And if I do that on both sides, thinking about if I'm raising x to the 6/5 to the 5/6 power. When you have your power rule, you are multiplying your exponents. You have 6 over 5 times 5 over 6. That's 30 over 30, which is 1. So we chose the reciprocal intentionally so that our exponent here on our variable would become 1. So x is going to be equivalent to 400 over 7 to the 5/6 power. That's not going to be a pretty number, and it's definitely not going to be something we can evaluate by hand. So I am going to leave it in exact notation, 400 over 7 to the 5/6 power, or if you wanted to put it in radical form, this would be the 6th root of 400 over 7 to the 5th power. Okay, on the next one, the first thing I need to do is subtract 12. So that's going to be equal to 500. Then I can divide by 4, and this one will evenly divide by 4, and x to the 5/8 will be 125. The reciprocal of 5/8 is 8/5. So again, that's going to, when you're multiplying by the reciprocal, you'll get an exponent of 1. So this is going to be 125 to the 8/5 power, or if you wanted to write it as a radical, the 5th root of 125 to the 8th power. Moving on to C, first I need to subtract 10. And then divide by 3. All right, now this is, to the 1/2 power. The reciprocal of 1/2 is 2, so I'm going to be squaring both sides. Again, that will cause my exponent on 6 minus 3x to be 1, so it's just going to be 6 minus 3x. And I know how to square 6, right? That's just 36. So this one is going to have a normal rational answer. Not all of them will, but if they do, it's well within your abilities to finish it through and solve it. And so on this one, we're going to get that x is -10. All right, next one. First thing I need to do is add the 3. And that's going to be -69, so then I can divide by -3. And that becomes positive 23. Now the reciprocal of both sides, the reciprocal exponent, that's going to be 3/5. So my exponent here becomes 1, and I'm left with 3x minus 23 equals 23 to the 3/5 power. Now x is not alone yet, so I'm going to need to add 23 and then divide everything by 3. So x is going to be 23 to the 3/5 power plus 23 over 3, or we could put this in radical form, and that would be the 5th root of 23 to the 3rd power plus 23 over 3. Let's do a few more for good measure. On E, I need to first add 6, so that's going to be 250. Then I can divide both sides by 5, and that is going to give me 50. Okay, my reciprocal exponent here is to the 2/3 power. And then I just need to divide by 8. So we can leave this as an exponent, 50 to the 2/3 divided by 8, or cube root of 50 squared over 8. All right, on F, I'm going to subtract 7 first. And that is going to give me negative 333. Then I can divide by -3, and I will get 111. My reciprocal power here is going to be to the 2/3 power. So that will make my exponent on this 1. So I'll just have 10x minus 9. So I will need to add 9. And then divide by 10. And I'm running low on space, so I'm going to put it over here. So we can put this as an exponent to the 2/3 power plus 9 over 10. Or we could put it as a radical cube root of 111 squared plus 9 over 10. Okay, last two. On this first one, I'm going to add 6. And that's going to be negative 324. Then I can divide by negative 4. 54 minus k to the 4/3 power is going to be equal to 81. My reciprocal exponent here is to the 3/4 power. So this becomes an exponent of 1. 54 minus k equals 81 to the 3/4 power. And then I am going to subtract 54. And then I'm going to divide everything by -1 to get that positive k. So what that's going to do is change the sign of everything. So k will be negative of whatever 81 to the 3/4 power is plus 54. Now, we have not drilled super hard memorizing perfect thirds, fourths, etc. So I would not expect you to take it further than this. However, if you did recognize 81 is a perfect fourth. 81 is 3 to the 4th power. So this could be simplified further. If I had the 4th root of 81 cubed, that is equivalent to 3 to the 3rd power, which is 27. So this is also equivalent to negative 27 plus 54, which is positive 27. Now, again, with how far we have taken it, I would accept this answer. But if you were able to recognize that you had a perfect fourth, you could take it further. Okay, our last one, I'm going to subtract 2. And then divide by negative 3. Our reciprocal exponent here is going to be to the 3/2. So 4 to the 3/2 will equal x plus 1. And then you are going to subtract 1. So I have 4 to the 3/2 minus 1 equals x. If I were to rewrite this as a radical, this is going to be the square root of 4 cubed minus 1. Now, I do expect you to recognize the square root of 4 is 2. So if this is 2 cubed and you have minus 1, that is equivalent to 8 minus 1. And so on this one, x would be equal to 7. All right, you can attempt the challenge on your own. I will put the answer down below. And so the solution to that challenge problem is -12. Again, you're welcome to work through that. If you get stuck and have questions, come see me. But we are low on time, so I'm not going to work through that one completely.